As I told you, multiple mails and messages regarding the topic called error, that viewers want to know that what do you mean by error. As I used to say several times, that confidence interval of the study we have to take 95%, and software is using the confidence interval by default as 95%, and there will be chances of error in our research always. So what do you mean by that error, and how we are going to minimize it, and what are the method? For example, if you got a type 1 error, so what are the method uh, by which mean we can decrease the error in our research here. So I will share my presentation to you, uh, so that you it will be visible. Yes. So topic called errors in research. Now in this context of testing of hypothesis, there are basically two type of error. Now, as I told you in the previous classes, that whenever we are proceeding for the research, we have to make the hypothesis, and after making the hypothesis, we have to test our hypothesis. So different methods are there by which mean we can test our hypothesis, and there will be chances of error uh, in the research. So error which we are finding in the research are classified into two different types, and two different kind of error we can make. The first one we used to call type 1 error, and second we used to call type 2 error. Okay, so whenever I used to say that 5% chances of error in the research, so you can take the example that 2.5% I am keeping for type 1 and 2.5% I am keeping for the type 2. Or it can be increased or decreased based upon the hypothesis which you have made, what was the objective of your test, which kind of study design you have chosen. Either you have chosen the correct formula for the sample size calculation or not. So based upon the different situations, these error can be increased or decreased. So what do you mean by the type 1 error? Type 1 error is called as error of first kind in the research. It occurs when the null hypothesis is true, but it is rejected due to unknown reason. Clear? As I told you in the previous classes also, that the whenever we will apply a statistical test, the aim of the test is to reject the null hypothesis. So error type 1 error occurs mainly when when null hypothesis is true, but you have rejected the null hypothesis due to any reason. So the rate of the type 1 error is called the size of the test. Basically, directly related to the sample size of the research, or the sample size which you have calculated for your research. So different Greek words are used. For example, here alpha is taken to represent the type 1 error, and most of the researchers are representing alpha label to represents the significance level of the test, what we used to call as a p-value. So it is denoted by the Greek letter alpha, uh, is equivalent to your type 1 error, and it usually equals the significance level of the test, as I already told you. And if uh, type 1 error is fixed at 5%, it means that there are about 5% chances in 100% that we will reject null hypothesis when null hypothesis is true. That means a confidence interval here we have taken 95%. Here I have not mentioned the word 95%, but you can assume that already I have written that if we are going to fix the type 1 error at 5%, so there are about 5% chances in 100% that we will reject the null hypothesis when it is true. So obviously the vice versa, we are assuming that 5% chances of error will be there, and that error will be type 1 error, and 95% of our data which we have entered, which we have collected, which we have gathered are genuine or accurate. Whereas second type of error we used to call the type 2 error, and it is also called a error of second kind. It occurs when the null hypothesis is false, but due to error we are failed to reject it. That means null hypothesis is not true, it is false, and we have failed due to any reason. We have rejected the we are not able to reject the null hypothesis. So due to error, we will be able to fail to reject the null hypothesis. So what about type 2 error? It means accepting the hypothesis which should have been rejected. That means uh, one example I'll take for that. For example, okay, how to differentiate both the kinds of error, that type 1 and type 2, because if you are going just words by word, it is most of the students will get confused. I'll just give a very simple example and easy to remember. For example, we have brought in house, and that house is having a facility of uh, fire alarm. Clear? What example I have taken, that we have brought in house, new house, and that house is having a facility of fire alarm. So, what is the objective of fixing that fire alarm in the house? That wherever or whenever the house caught a fire, that alarm should ring. Clear? I'll repeat again that what was the objective of fixing that alarm, that fire alarm in the house, that whenever the house caught a fire, that alarm should ring. So two kind of error can be occurred in that example. In first example, the type 1 error means house caught a fire, but alarm is not ringing due to any reason. So that kind of error will be called as a type 1 error in the research. I'll repeat again that house caught a fire, but alarm is not ringing due to any error or any reason. So that kind of error will be called as a type 1 error. Whereas false results will be given in the type 2 error. That means house has not caught any kind of fire, but whenever you are sleeping in the night, the alarm is ringing again and again. That means it will be called as a type 2 error, where the research is giving a false what word I can say, that research is giving a false reasons to justify your research. Clear? False alarm will be there in case of the type 2 error. That means house is not burning, but still the alarm is ringing again and again. You are going to fix the alarm, you will sleep, and after the 15 minutes or 20 minutes, the alarm will ring again. So that example can be taken for the type 2 error, or to justify both kind of error in the research, either type 1 and type 2. I'll repeat again that with the same example, that we have fixed an alarm in a house, and the objective of that fixing alarm in the house is that whenever the house caught a fire, that alarm should ring. So in type 1 error, what has happened, that house is burning but alarm is not working. And in type 2 error, that house uh, is not burning, but alarm is ringing again and again. So false readings will be given by the alarm in second type. So in second type, you can see it will be called as a beta type of error. A type 2 error is committed when we fail to believe a truth, as I told you in the example. And the rate of the type 2 error is denoted by the Greek letter beta. So it will be represented as beta and related to the power of the test, which is equal to 1 minus beta. Clear? So this table you have to see that how to see the error in the terms of null hypothesis as well as the alternative hypothesis. That means we have made a two hypotheses. The first one is null hypothesis when it is true, and the alternative hypothesis when it is true. So we will accept the null hypothesis, when it is true, so it will be called as a right decision. Clear? And one alternative hypothesis is true, and we are accepting uh, null hypothesis, so it will be called as a incorrect decision, and the kind of error which will occur in the research is the type 2 error or the beta type of error. So when null hypothesis is true and we fail to accept the null hypothesis, so that time again the decision is incorrect, and it will mainly occur due to a type 1 error in the research. So by seeing this table you will be able to find out that how we can correlate our null hypothesis and the alternative hypothesis, and either we are going with the right decision or we are going with the incorrect decision due to a error, either it is your type 1 error or the type 2 error or alpha error or the beta error. So always alpha error occurs, which is the most common in the research, when null hypothesis is true. Null hypothesis is true, but we will fail to accept it. Clear? And beta type of error occur when alternative hypothesis is true and we will accept that. So that kind of error is called as beta type of error. So you have to remember this table for the error. You can see the same diagram. When will you will be happy in the research, or if you're getting a type 2 error and your decision is not correct, you will feel sad. That means your null hypothesis is true, and it is, if it is accurate, and this will be donated as 1 minus alpha, and here you are happy. Clear? When the alternative hypothesis is true and it will be failed, you are not able to accept it, that time the type of error will be type 2 error beta, and you are feeling sad here. So the same table which I have shown you in the previous slide, the same, but the mode of presentation is different, so that by seeing this icon you will be able to remember that what the table shows. So here you can see the example that I have shown the error in two different color. The first one is we have a null hypothesis, and this one HA we have a alternative hypothesis, and both type of error are representing in two different color. We have a type 1 error which is representing in the form of yellow color till from here to here, and we have a type 2 error which I have represented in this sky blue color. Now we have a center line which is I have given in pink color. This is representing to a center point. That means if I will move this pink color line to left side or right side, it is going to increase or decrease the area of either the type 1 error or type 2 error. For example, if I will move this pink line to this side, to my right hand side, so the area of the yellow side is going to increase. That means whenever the type 1 error increases, the type 2 error decreases. Vice versa, whenever the type 2 error increase in the research, the type 1 error decreases. So if one error is increasing, either it is type 1 or type 2, the another one is going to decrease. That is the vice versa of both. So by this example you can remember this, that if you are going to increase the type 1 error in the research, the type 2 is going to decrease. So the same, that what was the difference between the type 1 and type 2, this I have already taken in slide number 1 and slide number 2, but this is for the student, that most of the examiner are asking a question either for 2 marks or 5 marks, that what was the difference between the type 1 error and type 2. So type 1 error is when a statistics call the rejection of a null hypothesis which are actually true. That means we are rejecting, but when it is true. And type 2 error occur when the statistics does not give enough evidence to reject a null hypothesis. That means the same example I am taking, that A is causing B, and when we are not able to prove with the proofs that A is causing B, that time we can say that null hypothesis is actually be rejected. So this is the examples and the difference of type 1 and type 2. A type 1 error is called false positive, and a type 2 error is called false negative. It is denoted by Greek letter alpha, it is denoted by Greek letter beta, and null hypothesis and the we used to call type 1 error, and alternative hypothesis comes under the type 2 error. So like this you can say, and there are other different type of error in the research, but basically in the books or in the different research paper or review articles you are going to find these two, type 1 and type 2 only. But others are also there, like I have mentioned here, measurement error, sampling error, frame error, random error. So as the name indicates, this kind of error you can make while doing your research. But it is, for example, if you are doing a measurement error or the sampling error, it is going to affect either the type 1 or either the type 2. So chances of increasing or decreasing the type 1 error or type 2 error can occur if you are not able to uh, what we used to say, that if you are doing a measurement error or if you are doing a sampling error or the frame error, so these kind of error can increase or decrease the chances of either type 1 or type 2. So we will just say that what you mean by measurement error, when there is a difference between the information we desire and the information provided by the researcher. That means if you are doing a error while applying the statistical test, for example, whenever you are going to compare two different variable, for example, one is your HbA1c and second one is your fasting blood sugar, both are used for the diabetic patient to know that what was the blood glucose level of the patient. So uh, one is one, the unit of fasting blood sugar is uh, millimole per liter, and unit for the HbA1c is the percentage. So one, if I'm using the digit 1, so 1 is not equivalent or the same for the fasting blood sugar and for the what you will call HbA1c. You can take one more example, that normal value or normal range for fasting blood sugar is 140, whereas the normal range for HbA1c is 6.5. So 6.5 and 140 are not the equal figures. Clear? So whenever you are going to compare these kind of variable which either each other, you have to standardize the units. That means you have to tell the software that 6.5 is equivalent to 140, which is the standard ranges. That if person is having value more than this, you can say the person is diabetic. That means fasting blood sugar, if you have more than 140, you will say person is diabetic. If HbA1c value is more than 6.5, you can say the person is diabetic. So here 140 and 6.5 is not equivalent uh, to the not representing to the same digits. That means here you cannot say that 140 uh, is similar to 6.5. So you have to justify and you have to standardize both the units. That means millimole per liter by percentage. Clear? So if you are not just justifying and you are not going to standardize your units in the research, it is going to cause a type of error called measurement type of error. Now another type of error is sampling error. It occurs when a sample somehow does not represent the target population. That means I want to conduct a study on males, clear, and the data if I'm going to take from the females also. So obviously that kind of error will be the sampling error. And for example, in during the study design, if I thought that I will conduct a study on a population having age between 30 to 40 only. So if I'm taking a sample size of age 41 patient, so that kind of error we used to call a sampling error. Another one is the frame error. So frame error is representing to a area where we have thought we will conduct a study. For example, if I want to conduct a study on a Moga district, so Moga district is having a different wards. Clear? So it is necessary for me that I will take a samples from the all the wards of the Moga district. it is not necessary that if my sample size was found to be 250, so all the 250 patient I am going to take from a ward number 1 or ward number 2, and no patient from the ward number 7. So from each frame we have to calculate the sample. So whenever we are not collecting the sample from the each frame, that kind of error will be called as a frame error. So error when a sample drawn from a population differ from the target population. So when we have a target population, we have already decided while making the study design, and if you are not following that, that kind of error we used to call a frame error. And the fourth kind of error is called random error. So error because the selected sample is imperfect representation of overall population. That means you during the study you have chosen that randomly you are going to take, like in the previous example when we have conducted the Mann-Whitney test and Kruskal Rowley, we have decided that we are going to enroll 100 patients, and we are not knowing from the beginning that which patient is going under which group. So as the patient will visit the hospital according to the his or her problem, they can go to any ward. Yeah, either they can visit the orthopedic ward, either they can visit to the dermatology ward. You are not knowing that the seventh patient who is visiting to the OPD will go to any ward. So if you have chosen the random sampling, you should follow that. And if you have chosen a particular model that the first patient should go here in group A, second patient should go into group B, so you have to follow. So if you're not following that rules which you have made during the study design, so that kind of error will be called as a random error. So different kind of error we have in research. So all these error is going to affect either the type 1 or the type 2. uh, Now main topic that how we are going to reduce the type 1 error. Clear? So uh, basically, whenever we are going to decrease the type 1 error in our research, the simple method is that we have to increase the sample size of our population until unless we are not getting the bell shaped curve. For example, you are conducting a your background is pharmacology, and you are conducting a animal testing due to on a any model. So in that time we have found that your null hypothesis was rejected due to any reason, and you are not knowing that what was the error in your research. That time what you can do, you can increase the number of sample first. For example, as per the sample size calculation, we have found that your sample size is 50. So after the 50, if you're not finding the justified result as per your hypothesis or as per your idea, in that time what you can do, you can increase the number of sample. For example, increase the 5%. If you have taken 50, you can go to 55. Again check the distribution. If it is normal, then okay. Otherwise increase little bit more till how much you have to increase, until unless you are not getting a bell shaped curve. So type 1 type of error or alpha type of error can be reduced by increasing the sample size of the study. So one option is there, increase the sample size in your study, the chances of type 1 error will be less in your project or in your research. So how to reduce the type 2 error? uh, Type 2 error can be reduced by increasing the confidence interval of the study. For example, if you have taken a confidence interval of 95%, make it uh, 96, 97, like that, so that you will be able to reduce the chances of type 2 error. So by increasing the confidence interval of the study, you can reduce the type 1 error, and by increasing the uh, sample size of your study, you can reduce the type 1 error in your research. So other different type of error are also mentioned by some other author. If whenever I was visiting to different articles, review articles which are written on statistics or mainly on the topic called error, so they are mentioning other errors also. So what now researchers they have done, any other type of error which will not comes under type 1 or type 2, they used to call this one as a type 3. For example, frame error, measurement error, random error. Now the scientists are calling these kind of error as a type 3 error in the research. So many statisticians are now adopting a third type of error, which will be called as a type 3 error, which is where the null hypothesis was rejected for a wrong reason, and we are not able to find out that what was the wrong reason for rejecting the hypothesis. Clear? So in an experiment, a researcher might assume a hypothesis and he can perform the research. So after analyzing the result statistically, he found that the null hypothesis was rejected. Clear? So any kind of error which will not come under type 1 or type 2, this will be called as a now type 3 error. So already we have discussed that two basically type of error we are having in the research, that is type 1 and type 2. This will be called alpha type, this will be called beta type. And what the things you have to remember, we have to remember this table, that if your null hypothesis is true and you are accepting it, you are making a right decision. If null hypothesis is true and you are not accepting, and due to any reason you fail to accept the null hypothesis, it will be called a incorrect decision. That means you are making an alpha type of error in the research, and vice versa of that we used to call beta error. That means your alternative hypothesis is true, but you fail to sorry, you accept that, it will be called beta error. So now I will let you know that hypothesis alternative and hypothesis null means what. Basically we can take the example that we want to compare two different groups A and B. Clear? Now null hypothesis says that both the group are equivalent. That means group A and group B have the same effect. Both are equivalent. So your aim of the research is to reject the null hypothesis, and you have to prove that there is a at least one difference between A and B. Both groups are not similar. There is a difference in both the groups, and aim of the research is to reject the null hypothesis. So like this we can follow. And if you have any queries related to uh, errors and the see, I will take one more class on the topic called hypothesis, that what was the different method of uh, making the hypothesis and how we are going to test the hypothesis in the further classes. So if you have any queries related to Mann-Whitney U Pushkal Wallis test through SPSS and the error, you can call me. You can subscribe my channel for more further videos. You can subscribe the channel of ISF College of Pharmacy, where you can find the live classes on the different topics. So after we will finish with the online series of biostatistics and research methodology, we are going to start another one after discussing with the management on a different subject. So meanwhile, this is all for today. Stay safe, stay home. Thanks for